Hello, this is a Unit 6 review for the final exam of ENGR 201. In this unit, I'm going to be covering over the forces. So this include work and proving that a force is conservative and solving for the f of x. So the first one, we're going to find the work. So work is just equal to f dot dr. So if we want to calculate that, we need to take the integral of it. So in this case, it's going to be the integral of f dot dr. So in this case, we have just r, so we need to calculate dr. So dr is equal to the derivative of each of these with respect to t, because this one will become, because we're solving for dr dt, and then we move the dt over. So we'll have 2 negative 2 sine 2ti plus 2 cosine 2tj plus 0k. Move the dt's over. And then we can f dot dr. So f dot dr is going to be, so we need to substitute. So we're going to have x, y times negative 2 sine 2t dt minus z 2 cosine 2t dt, and then plus 0. Now we need to substitute for the x and y and z. So your I term is your x. So this right here is x. This is y, and this is z. So when we go to solve for this, this would be the integral from 0 to pi over 4, because again, that is our limits. So xy, so x is cosine 2t sine, and y is sine 2t. So we'll have cosine 2t, and this becomes negative 2. This becomes sine 2t squared, and then minus 3 times 2, which is then is 6 cosine 2t, all times by dt. So just factor out the dt's to the very outside. So now we can integrate. So integrate would be 0 to pi over 4. So this would be our u, this would be our du. So when we integrate, this becomes sine cubed 2t over 3. And this becomes minus 3 sine 2t. From 0 to pi over 4. So pi over 4, so actually pi over 2, because it's 2 times t, which is 1 cubed over 3 minus 3 times 1. This is sine pi over 4. I'll write sine pi over 4 so no one gets confused. Minus 0, because again, sine of 0 is 0. And then this will just be 1/3 minus 3, which then would just equal negative, can't do this math right now, 9 over 3. So we got minus 8 over 3 units of work. Double check. Oh, oops. Made it math there. Oh, I forgot to carry my negative here. There's a negative here, so this is actually a negative 1/3, so that comes in minus 10 over 3. All right. Yep, f dot dr, let's work. Remember that your r of t, it's xi plus yj plus zk, and x, y, and z are all functions of t. So now, in this one, I'm going to be going over proving that a certain function is conservative. So in order to do that, remember, you need to do the partial of m, because remember this is mi plus nj plus pk. So it's partial of m with respect to y equals the partial of, so let's see. So you have to do all three of these combinations. So you make sure you have all of them. So partial of m with respect to y. So that equals 6x squared yz. And this is supposed to equal partial of n with respect to x, which equals 6x squared yz, check mark. So notice y goes with the n, m goes with the x. Then I want to solve for partial of m with respect to z, which then equals 3x squared y squared. And this should equal the partial of p with respect to x, which equals 3x squared y squared. Everything else goes to 0. So again, m goes with x, p goes with z, and these are good, so check mark that off. And then lastly, partial of p with respect to z, which equals 2x cubed y plus 2z, which equals partial of p with respect to y, which equals 2x cubed y plus 2z. The other term goes to 0, check mark. And again, just to show it, y goes with, that should not be a p, that should be an n. That's my bad. So that so it should be y with n, and then p with z. All right. So all three of them are check marks, so therefore conservative. All right. So now we need to find f of x, y, z such that del f equals f. So this basically just saying del f equals partial of f with respect to xi plus the partial of f with respect to yj plus the partial of f with respect to zk. So we're basically just going to be working backwards here. So in order to work backwards, so we're working backwards. We're going to pick out, and I always go solve for x, solve for y, solve for z. So going with the m, so the function of f of x, y, z equals the integral of m dx, which equals the integral of 3x squared y squared z with respect to dx. So when I solve for that, I want to get x cubed y squared z, and then now I might be missing a function, I'm going to call it g, of x and y, or sorry, of y and z. So this is like my constant here. So now I have everything that has my x's in it. So this is the only term with x's in it. So now I need to figure out my other terms that might have y and z in it, or just a constant. So now I want to take the same thing I just did here. I want to solve for fy, which equals n, which then equals the partial derivative of, again, I'm doing it with this. So it's going to be 2x cubed y z plus gy. Set the equal to n. So n equals 2x cubed yz plus z squared. So looking at it, these two terms right here are the same. So I'll cancel these out, which makes g of y equal to z squared. So solve for g of yz. So that means I'm just integrating z squared with respect to y, which equals z squared y plus some function h of z. So now I'm going to plug this back into here and then solve for fz. So, and then set that equal to p. So that means that now my function f of x, y, z is equal to x cubed plus x cubed y squared z plus z squared y plus hz. And then f of, so this implies fz, which equals p, equals x cubed y squared plus 2zy plus h prime of z. Set that equal to p, so which is x cubed y squared plus 2yz plus 3z squared. Alright, so these two terms right here are the same, cancel them out. These two terms right here are the same, cancel them out, which then implies h prime of z equals 3z squared, which then implies h of z equals z cubed. So I just took the integral of z with respect to z, which makes my overall function now, and most importantly, don't forget a plus c. So this equals x cubed y squared z plus z squared y plus z cubed plus c. And then you just plug in your values and for the function, because the integral of f dot dr is this function here. So you just basically solve for this. From this point to this point, and I don't feel like doing that math. It says unit 6, 8 equals 1. 8 equals 1. Alright, so now on to the next unit, where she'll get into line integrals and surface integrals.